Yes, okay. Let me put it full screen. Okay. This morning I thought I would talk about some issues that are part of a wider debate about digital social research. Now, I don't think I have to sort of make salient to you the fact that social scientific research has been affected a lot by the sort of digital revolution, in the sense that we have now a lot of opportunities to collect data by digital means, and that speaks very dearly to the heart of any social scientist, because let's face it, I mean, in the social sciences we always had a problem of data scarcity, meaning that data were difficult to obtain, they're very expensive to obtain, and once we had the digital, and we'll go through that with a large availability of data that suddenly appear, we were enthusiastic. I mean, and this enthusiasm led to a wave of research using data from social media, from other digital sources. But I think in this enthusiasm, which I ascribe myself in among the enthusiasts, certain methodological aspects were, I think, overlooked. And as we progressed and we tried to systematize the way how we do research using digital methods, clearly some aspects emerged as definitely in need of a further reflection. Now, when I say digital methods, is because there are a lot of terms used in this context. Another one, obviously, is big data, and big data are one particular type of digital data that we can use. But I think often they overlap. But I think the consideration I'm going to make today apply to a wide range of digital data, and that includes also big data. We started to see the application of digital data for a number of things. These are just a tiny small subset of things we can do using digital data. And the interesting point about digital data is that because of their diversity in the nature of type of data that we can collect, it gave a boost to a lot of different areas of research in the social sciences. And I think one big example of this is social network analysis, that of course is much older than digital media. But for a long time, to collect relational data was extremely painful and expensive. I mean, if you look at the history of social network analysis, people were collecting data by observation. So they would just sit there and observe a group and how they would interact with each other. And you can see the limitation in doing that in the amount of groups that could be observed for how long and so on. And then suddenly they had literally groups composed by millions of actors for years, and they could use this relational data in a way to progress quite a lot our understanding of social networks. But then of course there are other application of digital data. They go through opinion mining, the fact that we all know the surveys, probably the pillar of methodology in the social sciences, has encountered a lot of problems, from response rates to how much you can rely on self-reported data and so on. And suddenly we have these again digital traces that people live online for prolonged period of time, and also composed by a large amount of data points per person. I mean, in a very well constructed questionnaire, you can have 40, 50 data points per person. I mean, when you access, for example, a social media platform like Facebook, you have, and those are the ones they let you see, usually around 500 data points per person. So you can see that there are many applications, and then we can discuss that. But that's not the point of what I want to discuss today. There's also an issue, I think, here, that the digital is not only a field where you can do the type of analysis that you were doing offline. You do it now online, but it's also something in an environment that poses particular challenges that they are unique to the digital, and they are very interesting for the social scientists, but it also poses quite a lot of challenges from the methodological point of view in how to study this stuff. And these are some examples of digital challenges. This slide comes from a discussion about digital citizenship that I did in a conference with the European Union, let's say, expert group about this stuff. And basically, these are some of the areas where we know the digital is changing the way how essentially people behave, exercise their citizenship. So you have, of course, the false and misleading information aspect, but also the choice architecture, how people take decisions in online environment, and how the architecture of the online, the digital, shapes the way how people decide about things and decide about important things. Which pension scheme to adopt, or where to send, to which school send their children. And stuff like that. Then, okay, there's the issue of attention as an important commodity and so on. So overall, we know that if in the beginning we conceptualize the digital as pretty much as an additional field, I do a survey that I used to do offline, I do it online. I do interviews that I used to do offline, I do it online. Now it's very clear that it's not only a field, but it's actually an object of research by itself. What happens, and the boundaries between the two are so blurred these days, especially in advanced economies, that it's very difficult to make the distinction anymore. And we also have the issue that from a kind of social and also behavioral point of view, the digital has features that are very different. Well, they're quite different from we experience in the offline. We deal with groups of much larger size than we do in offline life. We have a much more information to deal with, but also we have limitless space of storing information. So an issue there of distribution of cognition there. But there is a very rapid change and adaptivity to this change. So things can be personalized, can be changed to individuals very, very quickly. I mean, an example of this is Google personalized search. When you go on a search engine, the search engine, Google search engine, will produce results in the Google PageRank type of output that is based on your past web histories. And that means that if me or you search the same thing, we will get different results, especially different ranking of websites. Then again, I mentioned choice architecture, the power of design. People take decisions, they do things, they act online, and there is an interaction between the architecture of this platform and how people behave. That's an important point. We will come back to that, because how much, if you take a platform like Facebook or Twitter, how much is the product of people's volition, and how much is an interaction of that and the architecture of the platform? Okay, so think about Facebook. You cannot put "I don't like" under a post or a picture. You can only put a like. Okay, so these are the so-called affordances. So how you disentangle that effect when you use this digital data as proxy of behavior. Okay, and that's one element to consider. And then, okay, there are other aspects about how people behave online. Again, we could talk for hours about that, but the point here is to talk about how those affect, so to speak, the type of analysis that you do. So while I came to realize that there are at least 3 points where we need to think carefully about digital social research that are not discussed that much. The first one is that because we had all these opportunities about data collection, we kind of forgot a bit about methodology, in particular about measurement, okay, which I will talk about it. And then we have some other problems concerning how we think about populations, how we think about access, and a number of other aspects. The last point is that there is a debate currently between, let's say, social scientists that deal with digital research, that some they think, okay, we need a canonized digital research, social research, that is anchored to what what we have done so far, so to speak. So has a continuity with the methodological principles that we adopted so far. But then there is another group of people that they call the natives. They say, no, forget about it. We need completely new approach with these guys. I mean, with this type of data. We need a digital native methods. And that's, to put it bluntly, the second group is usually identified with a group of people doing this type of research in Amsterdam, while the other one is more the let's say LAC, Essex, NYU type of people, and so on. Okay, so the first point that we have to put on the table is that as you go into the digital, the first big distinction you find is that you have two really big family of data. You have structured data and unstructured data. Structured data are the data that they have within, they already have a model of structure of how these data are produced, okay? And just to give you an idea, if you query a database, a relational database that is structured data, I mean, you have a field for a postcode, you have a field for an email, you have a field for a name. Those are structured because there is a data structure imposed on the data, okay? And structured data, we've been dealing with structured data for a long time. This is what we produce when we do a survey. We design structured data because we collect information and we structure through the structure of the questionnaire, okay? But online also, in the digital context, we have a lot of unstructured data. And this unstructured data, the easiest example, the first example is text. We have a lot of text that people produce that don't follow a structure, okay? So the unstructured data is a lot. It's actually the majority out there. And the problem is that the methods you have devised for structured data, they don't work very well with unstructured data, okay? And so why we now have seen the emergence of techniques like natural language processing, we talked about machine learning, because those were thought to deal with unstructured data, okay? Natural language processing is nothing else than a way to impose a structure, usually a mathematical structure, on text, okay? You use different techniques to basically impose a model on text, and then you do analysis on it, okay? For example, topic modeling, or in its different forms, and so on. So that's one approach. In machine learning, depends on what type of machine learning you're doing, it's a similar effort on unstructured data as well. In fact, can be applied also to text mining. So we have this problem that unstructured data is not a mature, I mean, there isn't a consensus of how to do things there, okay? People are experimenting. So we don't have a canon there at all. So we need to think how that impacts on our own use of this type of data in the social sciences, okay? Because when you use text mining, when you use NLP, it's not that you you have a goodness of fit. How good is your topic modeling compared to another form of topic modeling on the same textual data? So the okay, here I go a bit into the details, but just to say that the unstructured data are the prevalent ones online. Are all this type of information that you can find. They are not only text; they are also data that now comes from a sensor, for example, locations. You can have obviously pictures. You can have and of course, you have machine learning applied to pictures to automatically classify pictures. Again, is an attempt to put structure on unstructured data, so like pictures. So we have a lot of example of this, and so we can see why the rise of computational social science, so the introduction of these type of techniques has become necessary, because now we have a lot of unstructured data to deal with, and you cannot do a regression on unstructured data, so to speak. So you need all this process of transformation and application of a structure. Now, these are some examples. Okay, obviously, I then share the slide, so it also contains some kind of notes on what you can do. Interestingly enough, we have more and more machine-generated unstructured data. So not only ones that are generated by humans, the distinction between the two is becoming sometimes difficult to obtain. Think about the bots online. Okay, bots online are nothing else than software that mimics the production of unstructured data, text of humans. So you find bots on Twitter that they basically mimic what people would write, and then so you have also this additional complication in sorting out what is valuable data and what it isn't. But I want to so this is the kind of the big difference that I was saying before. So unstructured data are the target of these new techniques, NLP, machine learning, and so on, and their application to social scientists is an object of debate. We can discuss about it, but it's an important aspect. But I think there is another point, since I'm running out of time very fast, that another important point is that some people distinguish between design and organic data when we have to deal with digital data. What that means? Well, the fact is that a lot of digital data are there because they are collected independently of the interest or effort of a researcher. We automatically, as a society, record digital data about numerous activities and behaviors, and then the job of a researcher is to take this data already available, collected often with different purposes, or sometimes just with the approach, let's collect everything and then sort it out later, with the idea that you as a researcher, you need to, in a way, filter what is important for you and then transform that in indicators and variables for your own research. That's a very different process from design data, where we design the instrument and we design what are the variables that we want to collect, okay, the indicators and the variables. So we already know the concept, the properties we want to measure, the indicator and the variable. This is what we do when we design a questionnaire. This is what we design, an experiment. But that's not the case with digital data, because in most cases we repurpose data. We take data is already available and we try to figure out, how that can answer our own hypothesis or research question. So, for example, you study political participation. You go on Twitter and you say, well, if people share tweets from politicians, that's an indicator of political participation. Or if people follow a politician, that's an indicator of political participation. But that information is already there. You are attributing, that meaning to a particular set of behavior. So you're doing essentially something that is different even from what we know in the social sciences, because of course in social sciences we have done secondary data analysis. People take the data set of someone else and we use it for analysis. We do it all the time. But normally in that case, data have been collected by other researchers in most cases, not all, but it's very clear the purpose that they were collected and how they were collected. But in the digital, it's not that clear. I mean, if you take data from Twitter, Facebook, or Amazon or Spotify or whatever, they collect data for often very technical engineeristic reasons that are functional to them. You don't know what those purposes are, and you don't know exactly why certain choices have been made in measuring with one frequency over another, for example. Okay, so we found ourselves in the situation B rather than A. A was the typical situation that we had, and B is where we found ourselves. So B means that we have, variables here, and we need to select them and associate it to a property that then becomes an indicator and then becomes our variable, where normally we do exactly the opposite, okay? And the problem here is that how we select this, okay? How we make the decision here. Now, here we are helped by the notion of construct validity. Normally, we test what are the best measures, for a concept. And there are people that spend a lot of time in doing construct validity tests about scales. About the experiments are a bit different, but people do that. The problem is how you do construct validity of digital data. And that's basically one of the problems. So, sorry, I don't know why these things remained. Okay, remove them. Okay, here we go. So the problem is that, okay, of course, one indicator is not enough. We know that concept, especially concept in the social sciences, tend to be complex. We need more indicators. And that means that we need to construct validity in order to assess how much we analyze of a concept. And the problem here is that all the techniques we use to do construct validity in the social sciences, they don't work very well with digital data. So normally we have a couple of methods, let's say, that people use. Let's say the statistical way to do it is, a typical one is confirmatory factor analysis. People do that when they have to validate, for example, scales. And we design data with the data we normally tend to collect. That's fine. Then of course there is a debate there also which method is best, but there is a consolidated tradition about that. The problem is, if you try to apply that with digital data, you find a number of problems, which we'll discuss in a second. The other approach is the so-called multi-thread, multi-method matrix, the MTMM methods, which are very complex and very time-consuming, but some people do that. Is basically the idea here is that you assess construct validity when you measure the same construct using different methods. And those, they have to correlate more strongly than using another, compared with measure of different constructs with the same method. Okay, so that's the convergent validity approach. And the problem is that in the case of digital data, again, this is very difficult to do, and we'll come to a second why. Now, in the case of confirmatory factor analysis, the problem is that in order to do confirmatory factor analysis, you need several indicators for the same construct. Okay, and sometimes you don't have that in the digital because you have not selected the data to collect. Someone else did. Okay, so this is common, I have to say, also to secondary data analysis in the traditional sense. Okay, but is even more dramatic in digital data. But then you have another problem. The problem is that in the case of digital data, you have data that have been collected sometimes at very different frequencies compared to the traditional ones. when you collect a survey, when I mean frequency is frequency in time. When you collect a survey, what you have is all they're collected the same frequency. Okay, but if you combine, let's take a social media example. If you collect information about shares or comments or other activities there, they are collected at different frequency. Okay, some are also, if you add, for example, sensor data like location data, they can be very highly frequent. You can have information about location every second. Okay, so you have this problem that if you do confirmatory factor analysis or factor analysis with data that have different frequencies, that generates, first of all, in that case also you have a lot of missing data, can be the case, generates really weird results, very difficult to interpret. And so you have that problem. The other problem is that, sometimes, is that you have, if you use the other methods, if you use the MTMM methods, then what you have here, the problem is again, if you try to use data collected with different methods, what you have here again is you have different frequency, but also you have different scales, very different scales, I mean volume of data compared in these different measures. And what you find again is also the MTMM method, and perhaps then we can go into the details, it doesn't work very well because you have this very diverse type of data collected you try to bring together. And this is a problem that we are facing when we want to combine, for example, self-reported data and sensor data. We have developed an app here to collect data from a smartphone of people, and that's one of the problems. That is not obvious how you should unitize, so which unit you should pick for the sensor data, which, for example, can be location or can be some other sensor data, that they are very high frequency, they continuously collect data. Okay, how you match that with self-reported data that you ask only maybe 5 or 6 times per day? Okay, so you have these type of problems. Now, the construct validity, okay, which, just to summarize, is to make sure that you are measuring exactly what you conceptually want to measure, so to speak, is an issue especially relevant for social science research. Why is that? Because if you talk with computer scientists, as I do, they don't care about construct validity. And why they don't care? Because they are not so much in the business of explaining social phenomena. They just in the business of prediction. And if you're in the business of prediction, you don't care, if the variables are a good construct or not. What you only care if they're a good predictor, and you increase your accuracy, your reliability, or capacity of prediction. So they don't care. But if you want to explain a phenomenon, that means then you want to relate it to a theory. Then you need to make sure that the construct validity of your measure is there somehow. And I think in the digital domain, this is still, it's the Wild West, so to speak. So that's the situation. That's something I use in my classes about explaining, different validity steps you should endorse. And if you apply that scheme to any digital research process, basically digital research example, basically nobody does that. Okay, nobody does it, or very few, to be fair, very few. But not because sometimes they don't want to, because it's very difficult to do it. Okay, now people then discussed about what to do then, and they come up with this. They're only free of accessing validity in the digital, but it's still very open to debate. So the first one is structural signature. An example is, if I want to measure friendship online, I need to be sure that what I'm measuring is friendship. Okay, so one example would be that I collect data about the friendship network of someone offline, and then I collect the same person digital online friendship network. And then I compare these two networks and I have the same structural signature. In that case, I can say that the digital one is also a network of friendship because it resembles the friendship network I've collected offline. This solution sometimes works, but unfortunately, not always you can do this match between the offline and the online. The other one is find a relationship with a known construct. So if you take some information from digital data and you show that they are basically extremely high correlated with another indicator that you know measure that concept, then you can make the argument that you have construct validity. An example, in scientometrics, people are using the amount of visitors, so the web traffic that a journal generates, an academic journal generates, as a measure of prestige. It turns out that that is extremely high correlated with the H index, the impact factor of the journal. Okay, so they claim that to use that digital type of data, the web traffic, is an indicator of prestige because it's highly correlated with the impact factor of a journal. Okay, then of course that's a question. Okay, in the case of experiments, it's a different story. What I do is I do experiments online, I do it offline, I see if they bear the same results, so to speak, but that's a different story. The third would be if you can show that there is a clear interaction between offline, from the online and offline behavior. There is an influence of the online on the offline. So for example, if you show that, let's go back to the example of political participation, someone who is also doing activity online also generates activity offline of political participation. Okay, but again, this is easier said than done because you need to do essentially an analysis that includes both domains, and it would be very complex to do. Okay, I already talked too much, but basically I just mentioned two more things because, as you can guess, there would be many. The last 2 points I want to make is that when we talk about population in the digital context, we tend to assume that they are stable populations, as we think in the offline, but they are not. Populations about platform change very quickly. And so we have the problem that making assumption of a stable population in the context of the digital can be very, very risky. The second point I want to make is the issue of which is very much specific to online surveys. People now use a lot online panels. Okay, online panels is a substitute of traditional samples. There is a lot of reasons for that. I mean, and I won't go into the details, but the point here is that these online panels, okay, they've improved a lot. Now they are, let's say, more representative of the general population because they're not anymore just a panel of internet users or people online, but they are so-called pre-recruited online panels. You build a sample as you would do offline, and then you give people access to the online. And so that's why they're called pre-recruited panels. But there is a problem. We don't know the response rate of this process of recruiting. Okay, so we don't know how basically well built is this process of the pre-recruiting in online panels. We only know the response rate to our own surveys in online panels, and that creates an additional problem. So is the issue of the response rates. So you have the response rate at the panel recruiting stage and the response rate at the web survey recruitment. And you know the second when you do online research. You don't know the first, and companies, they won't tell you that because that's an indicator of the quality of their panels. And they won't say that very. I'm doing a large data collection as we speak in these days with a big company in Europe, and I had to press really, really hard to get that information, and they make me sign an NDA so that I could not reveal it to other people. Okay, there is more diversity. I didn't mention qualitative research, but also there is some interesting point that can be made. And there's also, of course, the issue of ethics and privacy. I didn't mention that, but of course we can. So Peter just said, just for us then. I will send you an email about it. We have the issue of course, the fact that that's particularly new to social science research, that we always had what in this taxonomy here I called obtrusive or reactive research, with the only basically we always had obtrusive reactive research. What I mean here is that we always done research collecting data where people were aware of our presence. Okay, even when you do ethnographic participant observation, people can see you at the end of the day. I mean, I spoke with friends anthropologists. They might try to blend in, so to speak, but still, they're visible. But what you got now in the digital is that you are also unobtrusive, non-reactive research. You can collect data without people knowing that essentially you're collecting data, and that of course generates the issue of privacy, and in part, the Cambridge Analytica scandal was an issue of unobtrusive research. People were not aware that they were part of data collection, and in other cases they're not aware they're part of online experiments. I mean, Facebook, Amazon, they change their platform all the time, and they put you in an experimental group without you knowing. Okay, and the point there is that there's also an issue. I mean, it's an issue from a methodological point of view, and it's also an issue, okay, from an ethical privacy, which I'm not an expert, and I won't dwell into that. Let's see. Okay, the native methods, the last point is basically the idea is, okay, what we do with these issues, we just say, forget about it. They are not relevant because digital requires rethinking from scratch methods. There are some people, for example, Richard Rogers, things like that, okay? And they present some alternatives or methods could be used. For example, harnessing Google search algorithm for research purposes and stuff like that. I think my personal position is that actually you cannot escape these methodological issues. Sooner or later, you can just forget about it, that they will disappear. And so I think we need to carry on discussing this stuff. Okay, and so these are other open issues that still need to be. So we need this canon, but we don't have it yet, and so we need to basically discuss more about all these other stuff. I'll stop you because I talked already too much. Sorry. Okay, these are the references, and I'll share the slide obviously, and you can contact me here.
Great, thanks a lot, Giuseppe. It's clear you can talk for days about this, but I think these are very crucial, important issues in social science at this moment. Our transition from face-to-face surveys to web surveys, big data analysis, and everything. It's good to think again about sampling, representativeness, validity, and all that stuff. So thanks a lot for that. I want to open the floor for questions and comments. It's a bit hard for me to see you raise your hand, so please type in the chat you want to say something and then go ahead. So who wants to start?
Don't rush all at once.
Angelica, go ahead.
Yes, hello. Well, thank you very much. It was a very, very interesting talk, and I also read about this topic. So yeah, it was very interesting and enlightening. I was wondering, maybe that's a bit of a general question, but you said you talked to computer scientists, and I was wondering in general how we as a field, as sociologists, social scientists, can make ourselves heard, because yeah, when you read these papers about, hey, we can collect data from all, we don't need samples anymore, we do see the problem of that, but sometimes it's a bit difficult maybe to be heard by the more technical computational people. So I was wondering if you have any idea, suggestion on how to, make ourselves heard.
Yeah, I think, you know, they definitely have a lot of, let's put it this way, I think it's very important that social scientists, sociologists, but also social scientists in general, they do engage in a dialogue with them, because my impression is that now that they have access to a lot of data concerning social and economic phenomenon, they will do analysis regardless of we are engaged or not. And I have to say, they can benefit quite a lot of interaction with social scientists. I think there are two areas where that is particularly important, is that they do claim often that they don't need samples, you know, they can access to entire population, but the reality is very different, because these data often are proprietary somehow. I mean, they are in the hands of platforms. They can be quite open in sharing data, but they always put some limitations to access. Sometimes they're not very clear, they're not transparent. I'll give you an example. You can access the API of Twitter to collect data, but then what happens is that Twitter puts a limit on the amount of tweets you can collect every hour. And so if you are scraping data of a huge amount, you know, there will be a cap, and you don't know where the cap happens. I mean, you don't know, you know, how that happens, so to speak. So you have to explain them, look, you don't have population, you have quasi-population. That's one of the last slides I put, is how you deal with quasi-population. The other point is that they can collect a lot of data, but they tend to, because they are into the prediction business, they go for the what you know, my British PhD supervisor used to call the fishing expedition, where basically you collect a huge amount of variables and then you go fishing and see what, you know, what comes out of it. And we know that that's I mean, again, if you're into prediction, it's somehow acceptable, but you know, there are issues there as well. But if you are into explanation, it's not. So your contribution in variable selection and model selection, because that's another point, model selection, which is, I think, us as social scientists, we defect a bit on model selection. We can contribute. So the main point there is that we definitely have to contribute, have a lot to contribute, but we need enough technical knowledge to be in the position to talk with them. And that means, you know, you need to know a bit about Python, you need to know about all this, you know, a bit of machine learning, of text mining, this sort of stuff. And to be honest, it's not think that we know, we've done stats before. We can definitely learn. I teach computational social science in the data science program to sociologists. You know, it might be hard in the beginning, but then they do learn, and they do excellent work, so often better than computer scientists. So, you know, we should try to be present in that kind of dialogue.
Thank you.
Thank you. Any more observations, questions?
I stand before your coffee break, so I understand.
Okay.
There are a couple of questions.
Yeah, that's two now. So Ira first and then Peter.
Okay.
Hi, I was wondering how often does the problem of the representativity of the data comes out, and how would you deal with it? Because I'm thinking that when you study, for instance, a political issue, people who are engaging with that politician who are talking about that issue are very selected, since they are expressing themselves. Whereas people who might think it differently do not engage with the matter.
Yeah, that's a good point. I mean, Well, first of all, the issue of let's say the difficulty to understand what is the population you are tapping in, it's very hard for two reasons. The first one is if you rely on, let's say, user-generated content, so what people post online, you have to face the fact that it's a tiny minority that actually generates content in many platforms. People don't realize that, but in several studies, what happens is about between 12 and 15% of users actually generate content. The others are just passive users. So if you tap into, let's say, I don't know, Instagram or Twitter, thinking, okay, I'm going to sample the content there so that I can say something about whatever type of population, you're actually sampling a minority of people that they are active on that platform. Okay, so it's not only about if you agree or disagree. Actually, regardless of that, it's a minority that actually puts something there. Okay, and so that's a big issue. When I hear people saying that, and I mean, there's been debates about this, of using social media data or other sorts of, let's say, opinion-based data as substitute to traditional surveys, I think that's very premature, and above all is unjustified the fact that you actually need both, because at the moment we cannot guarantee that what we are measuring digitally, so to speak, for the issue of construct validity, for the issue of representativeness of population, is actually reliable. And I think so that's a serious concern. I mean, obviously there are other advantages of doing things digitally. When you have a very clear defined population, for example, you study, I don't know, Facebook groups that has been there for 5 years, you want to, it's a large group, maybe 10,000 people, you want to study how they interact. It's like almost a case study if you want, but on a large scale. Okay, that's fine. You get so much information compared to what you could do in an offline context, and also longitudinally. But when we talk about generalizing to general population, that becomes a different story.
Okay. Well, I thought Peter had a question, but
I do. Oh.
And everyone has a question too. So, well, Peter first now. Go ahead.
Yeah. So, Giuseppe, thank you a lot. Thank you very much for this talk. It kind of checks all kinds of boxes of problems that we are experiencing at the same time with our projects, combining, let's say, Twitter data with normal data, and it's about time somebody kind of structured the debate a little bit. So thank you for doing that. And I have one additional thing, and well, it's kind of just a remark, or but a couple of years ago, I supervised a research master student who was doing research in Rotterdam. And well, he wrote a paper on, let's say, the promise of this large-scale data. And well, then he analyzed the literature about that. So didn't analyze the data, but he analyzed the literature about that. And it seemed that, well, just in this literature, the idea of theory was completely abandoned, right? So it's just reality. People like, they don't need to sample, that's true, but also they have the whole population, so just describe what is going on and everything will be okay. And he criticized it, and I really like that. And I constantly see how also our problems, how our projects have these kinds of problems. So you have Twitter data, for instance, but then the issue is, okay, so just about anything's possible, also any perspective, so as to try to get a good theoretical approach to those data, that's the issue, right? And this is where I see the divide, where sociologists kind of struggle with that, with choosing the right theoretical angle to approach these data, because they know that this kind of predetermines also what the results of their study will be. and others, like computational scientists, perhaps, or something, are completely unaware of this and just analyze stuff or something, right? I don't know. Do you think that's true or not?
Yeah, the tendency is this one. I wrote an article. It was actually a commentary a few years ago about these two cultures of modeling. Okay, it's actually I've not invented this. It's actually a debate in mainly statistics journal. Okay, because the interesting point is the interesting debate between traditional statisticians and these guys. They are let's say promoting the computational methods like machine learning and so on. And the debate was that you have these two sort of cultures. The one that is model based, which is basically what we tend to do. We think about a model usually informed by a theory. We select variables, and then for us, usually the main problem is to validate our selection of variables, but also estimate the relative importance of these variables. Okay. In the case of computer scientists, instead, they are more on this sort of algorithmic model of modeling, which is saying, I'll pick any model as long as it works and produce an outcome I desire. And that's the kind of prediction approach. So you can do a random forest model where there is a combination of variables that guarantees you a very high prediction. Then you look at this combination of variables, and you cannot make any sense out of it because they're all different things put together, and there is no coherent interpretation of what's going on there. They don't care. Now, as long as they were doing that before in predicting some outcomes that they were not social phenomenon or economic phenomenon, fine, okay. But when they apply to the context of social economic, then becomes a different story, I think, because then what you have is a situation that you say, a computer scientist comes and say, well, I can predict you the crime level of the city, okay? And maybe he can, but then he cannot explain how we can predict the level of crime of a city. And so you, as social scientists, but also policymakers, said, okay, but if I want to intervene, okay, what should I do? And there you just have the variables there. Okay, you can have the different level of importance of variables, but there is no theory to explain how you could intervene. And so I think that's a debate, but there are some computer scientists that are open to this. Okay, they want to engage to this. Others, they said, why do we need social scientists for? Okay, we can do it on our own. But we need to argue the fact that actually we are very crucial in this point of bridging the two. And there are now models that try to do this. Okay, try to combine the model-based with the algorithmic ones. And we can carry on the conversation about this, but those I think are the most interesting innovation in the field. Okay.
Okay, thank you. Yeah, so it's not just looking for prediction, but it's kind of high prediction fishing, right? Okay, Erwin, you had a follow-up to Era.
Yeah, first, well, very first, thanks so much for the talk. It was super interesting. Then second, first, I would love to have a reference about that combination of predictive and explanatory modeling, if you have it. And then thirdly, my question was, you talked a bit about the importance of validating concepts and indicators and stuff like that.
Yeah.
And one of the problems was the missing data problem, right? So there's a lot of missing data. My question is, my idea about this is that sometimes the fact that data is missing is also informative in itself. Right, so the fact that someone does not contribute to a discussion, that someone does not retweet or something like this is in itself informative. So how can we, let's say, separate the real missingness from the informative missingness or something like this? And can we use this in also validating our constructs?
Yeah, okay, so it's no mystery. One of the example of the type of modeling I was discussing is something called model-based recursive partitioning. I'll share the link perhaps with you guys. It's basically the idea of combining decision trees with traditional regression modeling. Okay, so the second point is, it's an excellent point. Missing data is often an object of, let's say, fight between social scientists and computer scientists, at least in my experience. Because for computer scientists, they just say, missing data, drop them, remove them. It's noise, okay? They use always this term that really disturbs me. It's noise about signals, okay? They like, signals as a term. But we know the missing data actually can be very informative, especially, I think, when you know that you cannot guarantee the fact that those active that you record in terms of data are representative of a population. So what you have here is that you have this almost interaction between people missing, people not interacting, and so you want, and those often are very interesting type of people that you want to know about it. And how to solve that? That's a big question. I don't have an answer to that. I think, people are experimenting to see what you can see patterns in missing data, let's say, that can help you to do that. But that's definitely one of the points. In fact, I mentioned in one of the last slides that missing data is one of the issues that people don't take in account enough, in a way blinded by the sheer amount of data you might have. You say, okay, I got missing data, which actually got often quite a lot, but they're not considered properly. So yeah.
Thank you. Then we may move now to the last question by Maya.
Thank you very much for this interesting and enlightening presentation. I think my question was partially answered when you mentioned that we can combine models with the algorithmic data to validate maybe the results we find. But I would like if you can elaborate maybe more on, because given that you cannot retrieve, like there is a cap, like the example you mentioned about Twitter, there is a cap for the population and you don't know who you are basically reviewing the data for, then that raises internal and external validity issues. So maybe if you can elaborate on that. Thank you.
Okay. Yes, I mean, I think the issue there is that, let's put it this way, there are probably two solutions to this. Okay, the first one is that it's probably not so much research related. Okay, there is a lot of debate in Europe about opening up access to data from this platform to researchers. Okay, I know there is an initiative to basically say, okay, Twitter, you got data about European citizens, you need to open it up completely to academic research, without any limitation. At the moment, what happens is that this access is based either on how much you can pay, you can buy data, or access acquired through different means. I mean, if you work at Stanford and your pal, used to be that you used to play football, now is works at Facebook or Twitter, just few miles down the road, they give you access and so on. So you have that problem. The other one is that the algorithms that the cap access and they do select, they're usually based on traffic. So the idea here is that because obviously they receive a lot of requests from not only people but also applications. If you want to study a phenomenon that is global and is generating huge amounts, okay, of tweets, okay, that's where the cap goes into place, because you don't know how many tweets per hour that phenomenon is generating. It could be easily hundreds of thousands, and then you have that problem. Now, some people are advocating a method that's actually used in econology, which is called, the catch and recatch method. So you try resampling continuously, different time of the day, in different moments. Okay, try to see that you obtain, you know, similar type of data to understand if, you know, this cap is actually biasing your data. But there is no easy solution for that. I mean, at the moment, I haven't seen a straightforward solution. So I'm sorry, I cannot provide that type of solution. But there are some attempts to deal with that. I think that now people will claim the time for their coffee break.
Well, Francesco still has a last question, and I cannot deny him. So.
Yeah, okay, I will try to keep it very brief.
Okay.
So I wanted to ask you, like, don't you think that perhaps the role of social scientists in analyzing these kinds of data can be relevant in dealing with the problems of like false positives, like in prediction? So for instance, a classic example is the censorship algorithms, right? So for instance, I am Spotify. I train an algorithm in order to exclude automatically bands or music bands that like use like a racist speech, and this problem is also, for instance, especially in YouTube, right? So I try to exclude automatically videos that use racist speech, but this is an issue that is really related to social scientists rather than computer scientists. As you said before, then computer scientists are more like interested in predictions, regardless of the fact that there may be a lot of false positives.
Absolutely, because I mean, it goes back to the old saying that, you know, if you only got a hammer, you only see nails, you know, problems as nails. And I think, you know, that's what happens with a lot of computer scientists. They think that any problem can be solved algorithmically, so to speak. And I can tell you, I mean, this in my experience is true. I'm part of this. I accepted just because I wanted to observe what was going on. I'm part of this group set up by Facebook on digital citizenship, and they truly think that, you know, everything about hate speech or discrimination, all this sort of stuff, can be solved getting right the algorithm to sort out things. And so you have the problem of false positive, but you just have the fact that, you know, it's arms race. People will find a way to make full of the algorithm type of discrimination. So you always have to catch up and find a way to discriminate better. And I think, you know, that's where social scientists can, you know, you can go there and say, look, perhaps try something else. Try, you know, to expose them to, you know, to diversity, for example. It might help.
Yeah, or you know, in videos in which they use racist like terminology, maybe they can use satire, or they do the imitations of people that use racist speech.
Francesco, think about what the alt-right in the US did with the cartoons, you know, the frog.
Pepe the Frog, yeah.
Okay, let's stop here. Thank you all very much for the discussion. Very nice discussion. Very good keynote, Giuseppe. Thank you very much. You already got a bottle of beer. It was a kind of advance surprise for this. Let's start the next meeting a bit later. So let's start 5 minutes later. 10 minutes to 11. We come back for the parallel session. Okay. Enjoy your coffee or whatever.